Hello, hi guys. Welcome to this video. So in this video, I'm going to talk a little bit about the axis stream adder. So if you remember last week, we have been done the axis adder, which is putting data on axis light interface. Today I'm going to do a more involved version of the axis adder. It's going to use the axis stream adder, and perhaps in a later video I will compare the performance of using the axis interface and axis stream interface. So I just made a um, folder called axis stream adder. So I'm going to go to the axis stream adder folder, and I'm going to call Vivado. So we are going to start with the axis stream source code. I'm going to just use Vivado to package the IP without using the HLS. Hopefully this is going to give us the best performance because you are directly working with the hardware. It's like RTL level optimizations. Um, so let's wait until Vivado has been opened. Yeah, so I have so if you look at my other GitHub repository, the decision tree overlay, I've been using both the Axie-Lite interface and Axie Stream. So that's a better example to do the combination of the two interfaces. But today I'm going to just use Axie Stream interface. Let me create a new project. Next, going to call it Axie Stream Adder, maybe. I don't know what I did for the other one, for the Axie Adder, but I'm going to just use this one. Do not specify source, or maybe we can just add files later. Um, no, not this way. Create a file name Axie. Just to be consistent with the names, let's just check the name I did for Axie adder. So give me just a second. Let me see Axie adder. Um, Axie adder.v. Okay, so we're going to Axie s adder. I don't need any constraint. So this is fine. Finish. Let's wait. So this is just creating the RTL code. Like this is supposed to be the IP project. If you already know how to do this, you may skip to later version, I mean later part of this video. But let's just do, um, start from the very beginning, from scratch to build the IP. So let's open it. I think let's open the axadder.v so we can directly borrow something from there. Let's just copy it and paste it here. Oops, something. Okay, this is the axadder we did last week. So if you check the module name, if you want to change this to be like a axis stream thing, one thing that I want to do is I want to make this sequential logic. I want the adder to be able to pipeline the results. So for that reason, you need to kind of have um, a clock signal to, to synchronize all the signals. So I'm still going to leave the parameters with there, but the model name is called XC adder, and we're still going to have A, B, and C. But right now, I think I'm going to um, make, well, um, I think I can put it there. Um, I can do, well, I do need a additional input. Let's put it just right in the very front, in the very front. Um, Clock. I also need a reset because sequential logic usually you want it to start from a known state. So I can do always at pause edge clock, reset and pause edge clock. So if, well, let me think. Usually the reset is negative. I mean the active low signal. So I'm going to name it as reset n. So if reset n equals one, equals 0, then, well, maybe I did something wrong. Security. Um, I don't remember the, is it this one? Yeah, begin has a colon there. Else C equals A plus B. Well, it has to be sequential logic. What am I doing wrong here? Mm, Sorry, I apologize for the delay because it hasn't been a while since I programmed the Verilog code. Okay, I think I know this. It should be like this. If this one should be fine. Okay, no colon. Else, no colon. There's syntax error. Let me check. Oh, um, is it like this? Yeah, okay. Just stay. Oops, something is still wrong. Oh, begin. Okay, this time it seems fine. So, well, I still need to, yeah, so if the, okay, else, I think if clock, um, yeah, I think this time, so this is like asynchronous reset. So if, um, you know, it doesn't depend on the clock because reset n is also in the sensitive list. So this time it should be fine. So I just need to package this IP. Hopefully there's no problem with that. I need to create a new XC4 peripheral. Name will be XC stream adder. Um, Description X stream using XC stream interface. It's fine. So S00, well, if you have, so my intention is to put this clock and fit in those signal reset and clock from the XC stream interface. So I don't really need any XC interface. So I just need to use stream there. And I need one slave to give the input, and um, I need one master interface to output the C value, the final results. So I'm going to put next. I think this is fine. Looks fine to me. Edit IP. It's going to open a new project just as we did before. Um, well, uh, strictly speaking, you will have to simulate the IP to kind of give a test bench to test it. But because this Verilog code is very simple, we will just skip that step. But in reality, you should verify the design. We will probably see errors, when we build the project, but we'll just assume that it's going to work. Family, add family. We don't need all the families. All we need to include is zinc and zinc ultrascale. Life cycle is, let's call it production, maybe. Let's see, life cycle, pre-production, maybe. Okay, I don't need this vertex 7. Um, I'm not going to put that IP on vertex devices. Well, I need to add additional codes, I think. So there are two parts right now already being added. Um, One is the master interface and the other is slave interface. I'm not going to reuse this one. Well, if I want, I can always reuse, but I will copy some of the codes in my decision tree overlay here. So let's get there. Because I'm too lazy to, change any of the code. Not here. HDL. Master and slave stream interface. So it's in master. Just copying this to the master. Paste. Oops. Something. Slave. Go to slave. Well, you can. Well, a better practice might be just start from that, that original code and do slightly some minor modifications. But I always like my part of the slave and master because it has been verified. So let's look at this code. I don't want to, some of the parameters are coming from the decision tree, but in our new IP, all we need to provide is the width, right? It's the adder width. So we just assume that adder width is something like this. While data width is 32. Address width, we don't need that actually. Yeah, we do need that. It's the five it's related to the 50 depth. So width is 4. Let's see. local parameter width. There's a width it has already been used, so maybe we can call it adder width. So those are, you know, so we are saying the adder width is the actual width um, of the adder, right? So others are just some axis stream database, which is uh, you know predefined. Master, we're doing the same thing. Oh, by the way, have to change the name. Axis stream adder v1.0 s00 axis stream. This is the same. Axis stream adder v1.0 equals 4. Then data width is 32. All right, looks fine now. Oh, not data width. Here should be adder width. Looks fine now. So we need to add this one. Oops. Click. Need to add a source. Add. This is the axis. Where's the other one? Yeah, it's updating. Yeah, axis stream adder. So if you check, it's axis stream adder. So in the top level, this is the top level thing. We need to kind of put them together. User to add parameters. So I will call it parameter width equals 4. Hopefully width has not been defined yet. I mean, has not been used previously. So to those are the very, I have to provide exactly the same interface name. Let's see. It should be those 4. Well, clock reset input axis stream. Let's see whether it has to be updated. Yes, I do think we need to update this. So clock reset. Oops. Let's put it here. Oops. T ready, T last. Okay. doing wrong here? I think I need parameters also need to be defined. Adder width, well, actually other parameters I don't have to change them, so just leave them there. So adder width is now should be put it should be put you should put width there. And then for the master interface, we have to do the same thing. Adder width. I don't need anything else, right? Yeah, I don't need. Other inputs we'll figure it out later, but I will just make sure all the reset. Well, input XC, is it the same? I think I can just copy here. Okay, let's see how we should connect them. So you see this slave is the input part of this IP, and this one, this M00, the master interface is the output part of the IP. Then we also need to add axis stream adder. Yeah, so we have clock signal, reset signal, dot A, dot B, dot C, right? So if we double check clock, okay, reset N is called reset N, A, B, and C. Okay, let's see how we're going to connect them. So if we check, well, also need to check the, let's close this. Clock at 00XC stream A clock. This one is also going here. Reset. Should that be, well, it's A reset N. Is it doing the negative I mean the low active reset? Let me check. So I think, well, hold on a second. Let's check. I think I do have to. Yeah. So reset has to be negative. Well, this one should look like it should look like this. Okay. This is S00XC stream, not T ready, but I think this is going to be T data. XC T valid. Well, not input, but I think this is S00. T valid should be T ready. Let's see how I connect them. Okay, I think I need to provide the T-ready signal. Um, I need to generate the T-ready signal somewhere. Um, well, the axis stream T-ready. Do we have that? Yeah, we have that. Those are input T last. Yeah. Output need to give XC. This is output. So C. You should put some additional wires there. I think I need to do that. Let me double check. Just want to make sure that I'm not doing anything too strange. Yeah. So need to define those wires. User to add ports here. I don't need ports, but I need some wires. Well, not where. Yeah. T valid XC stream to pipe. Let's call it T valid. Oops, what am I doing here? XC stream to pipe. T ready. C stream to pipe. T last. Then I need is this defined? Well, stack count. Well, I just remembered I don't have to define that. Well, let's see. To define this, well, this should be pipe to axis stream. Should be master, I think. Decides to delete this. I may not need to use those, but just keep it there. I think it should be using this. Yeah, so this exit the T data will be the output T data will be this thing. And T valid, just copying T ready, T last, similar thing. Well, output first. Well, input first maybe. Axis stream T data will be the pipe to axis, this one. Pipe to axis stream. T valid will be this thing. This should be connected to the output, which is T data, T valid. Valid is here. T ready is hold on a second. The T ready should be coming from let's see, double check this binary tree exe t ready should be output. So, well, let's check the interface. Yeah, t ready is the other direction. So it's always coming from the other direction. So t valid, t ready, and t data are coming to the input ports, but t ready is some value, some signals returned on the output side. Some. So it's like a some feedback loop. So this is fine. T ready. Let's see. T ready here. T last. Hopefully this fine. So actuator clock will be since that we will connect them, the S0 axis stream A clock and the M00 axis stream A clock to be the same clock. So it's fine to just use any one of them. Reset N, the same thing, but the only difference is it's already reset N, so we don't need to add the negative logic. So dot A will be, I think it will be connected to the axis stream T data, while it's the output side. This one, but it's only going to be the width -1 to 0. Then B will be 2 times width -1 to width. And well, yeah. C should be the output. Where is the output? So width +1. So let's double check. Yeah, so it's width +1 bits because when you're adding two numbers, you're getting one more bit for carry in. This should be fine now. So all looks good now. I just want to run synthesize to make sure there's nothing wrong, but sometimes synthesize is not able to capture the actual um, errors. So we'll just give it a first try. Hopefully we are not driving any inputs with two signals. That will be a terrible mistake. While it's synthesizing, let's just double check. Synthesize failed, which is okay. We're not able to, let's see the problem there. Name port connection reset does not exist for instant. Okay, so it might be the reset name is a different thing. Let's check. Okay, it's RST for the master. It's the same for the slave interface. So we don't have reset, so it's RST. Same for this, but hopefully this is the only one. Let's synthesize again. Synthesize also still failed. Let's check. Not supported mixed level sensitive and edge trigger event control. Let's see. Maybe this should be OR. Another thing that I've noticed that haven't specified the relationship of those uh, valid signal. So I should probably, add additional logic to kind of feedback the T ready. So if you check the decision tree, I think I did similar thing. Valid. Oh, I think I know what I missed. I need to kind of pipeline the valid and the last signal as well with the data. So when the data is coming through the pipeline, you're also pipelining the valid and the last signal. So that's something I missed. I need to do that. Valid in, valid last in. Um, so go to axis stream adder. We will put additional ports. A second, let's check. T-ready should be the other way, I think. Valid in, valid out, last out. So valid in, last in. So pipe to axis, well, the should axis stream to pipe T valid to put it there. Then pipe to axis stream T valid should be the output. Last in should be, well, should put it similar thing. Yeah, we are piping through the signals. So data is coming through, you see. Valid is coming through, last is coming through, but there's a T ready, which I think I need to assign. So the assign the T ready is the on the master side is the input. So I put the input here. Um, so we need to, so on this input side of master side, this T ready should be output pipe to axis stream T ready. Let's check. Yeah, T ready is the output. So this output is coming back to the input, which is um, this one. So let's assign. This time it should be fine. We have all the signals connected. The data, valid, ready, and last, all the signals are taken care of. So data is being piped. Valid in, valid last in are being piped as well. The T ready, I can directly feedback from the XE master to XE stream, telling that you are able to proceed. So let's run synthesize again. Okay, still the same thing. I guess it's probably the sensitive list. So well, actually we just that in that case we just keep it synchronous reset. It actually doesn't matter. So let's just keep it synchronous reset. Um, it's only one level of pipeline, so it shouldn't even give us any problem. Let's run synthesize again this time. So the sensitive list only has one signal there. Okay, this time it seems like it's happy. So at least we have not identified any additional problems. So we just assume this IP is good. So let's just package it. Let's double check. Compatibility, is fine. File groups, merge changes, customize parameters, start count. I don't think I have that, but yeah. So we don't need to, we just need to put this, expose this visible. I think last time we did 2 to 16. So this time we will do similar thing. So range of integers, let's do show range. It's fine. Default value is 4. Okay. This thing, we don't want it to be visible. This thing, don't want it to be visible. So only change the adder width without changing any other parameters because the default one is always 32 bits for XE stream interface. Addressing a memory, I don't have the custom, does not support the current part. What's wrong? It's being reloaded. Do I have some additional ports there? T strobe, I'm not using that. Should I delete them? Maybe I need to. I think it's fine to keep it there, but it's just not getting any value. I can't see the GUI because something is loading there, but well, let's not check that. So actually adder 1.0, okay, setting. I don't want to close it. Just minimize them. So right now we are happy with the IP. So I need to create the project. Let's call it PYNQ XC stream adder. I'm going to take a shortcut, kind of cheating, because we already did an XC adder. Um, let's copy the PYNQ um, add. Well, let's first make sure that have the similar path. C1 XC stream adder make dir IP make dir. Well, let's copy it there. So it's going to be pretty large, but we will skip the bear one because last time we started from the bear. So the IP has to, copy from the location where we packaged the IP just now. I think it's IP development, XC stream adder, IP repo, I think. Yeah, this is it. Workspace. Looks good. PYNQ So we will go inside that and replace our XC IP with the XC stream IP. Um, so the block design is going to be a little bit different. So we need to be careful there. We need to add an XC DMA IP as well. So let's wait and see. So my plan is to modify the IP and then kind of write a new BDT code to replace the old add .tcl. Then we'll just use the add.tcl to create the project and do the implementation. So let's see. So later we will probably change the name a little bit because last time we called this project add. So maybe this time we call it add to or add something. Otherwise, it's going to be two overlay with the same name. It's a little bit confusing. So let's see. What do we have last time? We put an XC adder there. Just delete this thing. Need to Do I have to set IP repository this time? Yeah, this is the correct one. This is our IP. Well, do we need XC stream direct? I don't need the scatter gather DMA. I just need the regular interfaces. Scatter gather. Enable read channel, enable write channel with a buffer length 14 bits, which means you cannot put a lot of data. It's the length can only be like 16K data every time, and each data is 32 bits. This is fine. We're not going to test a big chunk of data. So let's see how we connect them. So first of all, this PS7 also need to enable HP port, at least the HP0. Keep in mind that you won't be able to use that port in your DSA file. So I need a XC interconnect as well. Because last time I think we did a XC internet connect. Well, not this one. Sorry. Still XC. It's really slow now. I don't know what's happening. XC interface. So the GP port has to go to the XC interconnect. Let's see, it's already going to XC interconnect. And then this one, this XC, because it's a GP port, it should go to the XC Lite interface, but we don't have that in our IP, so we can just control the XC DMA there, and then the XC DMA has the master interface, goes to XC interconnect, go back to slave XC HP port. So the two, I need to have two slave interface, but one master interface. Because my XCDMA needs two slave. So this goes to S00, this goes to S01, this goes to HP0. So then this memory XC, well, this goes to the XC stream. This one goes back to this thing. Seems like we completed the loop. Looks like we have connected all of them. So now it's the clock and reset in. It's pretty simple because we are just using F clock 0. So just connect all the clocks together. All of them have to be 100 megahertz. Oops. Goes here, here, here. Reset. Should be fine now. Let's verify the design. I'll run. It still shows to run connection automation. So this HP050 control, do I have to connect that? I don't think so. So I think this is it. Let's just validate the design. Okay, address editor. I almost forgot. I need to perhaps, this is the XC. I need to assign address. So seems like everything is good. Okay, validate design. Hold on a second, let's check. Where am I connecting? Oh, I didn't connect them. So this thing, it's this thing. This is fine. I think we know what this is about. This is the DDR setting. Actually, it doesn't matter. But let's save it. Validate design. Because the PYNQ DDR setting has a strange negative value, but I think this is fine after I save it. So I'm going to just use red BD tickle. Okay, so I have that thing add. Well, probably call it add to, or add axis stream. Well, what's a better name? Maybe add to. I should call the original add one or something, but just to differentiate those two. Put the I copy the all the tickle file I need. Make file, check add. Those tickle file. Other files are just generated, and the new tickle. We'll compare those two and make the necessary change there. So let's see. Well, it's too large. New tickle compare. Add tickle. Well, it should be called add to, so let's just make the change. Let's S add S maybe as or add stream. Control words. Okay. So from here all the way to the bottom, I think. Yeah. Okay, I just copied the new tickle here. So now it should be fine now. The only difference is there are some parameters that has been set correctly. So go to our add tool. So as we said, this one should call as. We'll probably close this one, but let's just leave it open unless we find something strange. We have to update the project. So the add tickle now is called adds.tickle. New tickle we don't need anymore. Build as build stream check as. Oops, wrong place for the stream. Add a stream. Let's check as.tickle is supposed to be fine now. Make file name has changed. Close. Overlay name, design name. It's fine now. Build bitstream. Fine. DSA. One thing that we have remember is HP0 has been used. We cannot use this one anymore. So that's the only change. So where are we? Add. Well, let's close this. Let's close the add one because if we want to make change, it's going to be the as project. Then we can take a break after this. As, well, oops. Okay, let's wait until it finishes the implementation. It's going to take a while, so let's take a break here. Oh, just one thing. I just exit the build process because I noticed the one additional thing is that when I copy the tickle file from the new.tickle, this name has to be corrected to as because last time in the new.tickle is called add. So I just need to correct that and remake. Okay, finally, I think I've finished the building of the overlay and I copy them onto the board. So if I check here, I have my ads.bit and ads.hwh copied from the project repository. So I think it's here. Copy those onto the board and I wrote this notebook. I spent quite some time to polish this, so I have both the Axis Light interface adder and the Axis Stream interface adder in this notebook. So I'm going to run this. First, I just test 200 data. I allocate the CMA array, contiguous memory array. I just use the same input buffer for both the Axis Light and the Axis Stream, but the output buffer will be, the results will be saved into different buffers for the two types of adders. And then I use some random data to populate the input buffer. So first time we will just download the add.bit and then I get this thing wrapper, of using this addition. Then I just record the time into t underscore add. Now the Axis Stream for the Axis Stream version, kind of do the similar thing. I download the ads.bit with an s and get a thing wrapper for the ads underscore data. Um, so I can also record the time when adding 200 data. Now is the important part. So I can make sure that the two versions of the IP get identical results. So, when I save the data into out buffer for out buffer 0 in for the Axis Light interface and out buffer 1 for the Axis Stream interface, I compare the results to make sure they are the same. And then since I also measure the performance, you will see for the Axis Light header, you will get this like 48 millisecond. This is 3 millisecond for Axis Stream header, so the Axis Stream header is giving you much better performance. And most importantly, you have to free the memory because contiguous memory behaves slightly different than the NumPy data. So NumPy data is taken care of by the uh, Python interpreter, but for the contiguous memory allocator, we also have to free the memory at the end. So if you check the official PYNQ notebook, we always free the memory. Otherwise, if you just ignore this, the final this final cell and just keep running this, eventually you will run out of memory and your Jupyter notebook will die. So the kernel will die and you will have to reboot the board. So that's a bad thing to have because you have memory leaks in your program. But now since we have done everything, you can see, you can have a try with your own IP. So that concludes this video. I hope you enjoyed this video. Leave me any comments if you have questions, and um, I will, maybe upload this somewhere in my GitHub repository. But I don't have a good idea of where to put this right now. But hopefully I can put this on the website so people can have a look. Okay. All right. Thank you. Bye.